Your soil is dying, and the people selling you fertilizer know it. They have known it for 50 years. Buried inside a forgotten research project from the 1970s at the University of California, Berkeley, sits a 14-day recipe that can bring biologically dead dirt back to life using nothing but the yard waste you are already throwing away. No bags, no consultants, no soil tests, no permission. In the next 10 minutes, you are going to learn exactly how this method works, what makes it so threatening to a $200 billion industry, and how to build one of these piles in your own backyard this weekend. Before we get to the recipe, you need to understand what's actually wrong with the dirt under your feet. Most people think soil is just ground up rock with some plant matter mixed in. It's not. Healthy soil is a living ecosystem, more crowded than a rainforest. In a single teaspoon, you have billions of bacteria, miles of fungal threads, protozoa hunting like microscopic wolves, and a web of arbuscular mycorrhizal fungi that actually plug into the roots of your plants and trade nutrients for sugar. That entire ecosystem is what makes soil alive. And in most farms and gardens across the developed world, that ecosystem has collapsed. You can spot dead soil the moment you look at it. It's gray instead of dark brown. It compacts under your boot. Rain hits the surface and runs off instead of soaking in. Plants grown in it look stunted no matter how much you feed them. Organic matter, which should sit between 3 and 6% in a healthy garden, drops below 1 or 2% in degraded ground. Decades of aggressive tilling, repeated blasts of synthetic nitrogen, and bare exposed ground in winter have torn through that microbial population like a wildfire. And here's the cruelest part. The conventional response to dead soil is to dump on more nitrogen, which accelerates the very death spiral that killed it in the first place. You're not feeding the soil, you're feeding the symptom while the patient bleeds out. So how do you actually bring it back? You can't buy living soil in a bag. You have to rebuild it. You need to re-inoculate the ground with living microbes, and you need raw organic carbon for them to eat. Which brings us to a quiet experiment that happened on the Berkeley campus more than 50 years ago, and to the recipe that came out of it. But there's a specific reason this method works in 14 days instead of 14 months, and we'll get to that in just a moment. The Berkeley method was developed at the University of California to compress what nature normally does in 6 to 12 months into roughly 2 weeks. The researchers figured out that compost is not slow because it has to be. It is slow because most home piles are too small, too dry, too unbalanced, and turn too rarely. Fix those 4 things, and the entire timeline collapses. The first rule is size. Your pile has to be at least 1 cubic yard, which means 36 inches wide, 36 inches deep, and 36 inches tall. Smaller than that, and the pile can't hold the heat it generates. Bigger is fine. Smaller is a deal breaker. The second rule is the ratio. You need roughly 25 to 30 parts carbon to 1 part nitrogen by weight. Carbon comes from your browns, dried leaves, straw, cardboard, wood chips. Nitrogen comes from your greens, fresh grass clippings, kitchen scraps, coffee grounds, manure. The research actually shows that a 35 to 1 ratio extends the hottest phase the longest, which is exactly what you want. Too much nitrogen and your pile turns into a stinking ammonia slurry. Too much carbon and it just sits there doing nothing. The third rule is moisture. The whole pile needs to feel like a wrung-out sponge, roughly 50 to 60% water by weight. Grab a handful and squeeze. A few drops should bead between your fingers. If it streams out, it's too wet. If it crumbles dry, add water and mix. And the fourth rule, the one most people skip, is oxygen. You turn the pile on day 4 and then every 2 days after that. Every turn pumps fresh air into the center, and oxygen is the accelerant that drives the entire process. Skip a turn and you fall back to slow anaerobic decomposition, the kind that smells like a sewer and takes half a year. When all four conditions are right, something genuinely incredible happens inside the pile. The internal temperature climbs to between 130 and 160 degrees Fahrenheit. That is hot enough to cook weed seeds, kill pathogens, and break down tough lignin and cellulose that would normally take a year to decompose. If you stick a thermometer into the center of a properly built Berkeley pile on day 6, the probe will come out warm to the touch. On a cold morning, you will see steam rising off the top every time you turn it. That heat is the signature of a microbial population doing roughly a year's worth of work in 2 weeks. Now here's where the recipe gets interesting and where most online instructions stop short. The Berkeley method on its own is powerful, but if you want to truly resurrect dead soil, there are a handful of add-ins the research community has quietly validated over the past decade. The first is biochar, which is essentially charcoal made from pyrolyzed plant matter. Mix it into the pile at around 6% by volume. Biochar is riddled with microscopic pores, 2 to 4 millimeters wide, that act like a microbial hotel. Beneficial bacteria move in and never leave. Combine biochar with a compound microbial inoculant, and recent studies show the pair outperforms either ingredient used alone by a wide margin. The second add-in is a microbial inoculant itself, used at just 0.2%. That's barely a sprinkle. But it introduces thermophilic nitrogen-fixing bacteria that have been shown to reduce nitrogen loss from the pile by 24 to 29%. Translation: more of the fertility you build stays locked into the finished compost instead of evaporating into the atmosphere as ammonia. The third is a manure activator, a small amount of fresh cow or chicken manure mixed with straw at that same carbon-to-nitrogen ratio. Drop it into the center of your pile, and the thermophilic phase kicks off within hours. And the fourth, applied not to the pile but to the soil itself when you spread the finished compost, is mycorrhizal spores. These are the fungi that physically plug into plant roots and extend them by 100-fold or more. Research has shown these fungal partnerships can mitigate damage even in saline sodic soils that most farmers have written off as unrecoverable. So let's walk through what's actually happening inside your pile, hour by hour, day by day. In the first 3 days, mesophilic bacteria, the ones that love moderate temperatures, explode in population. They're breaking down sugars and proteins, and they generate heat as a byproduct. Internal temperature climbs from ambient to around 100 degrees. On day 4, you turn the pile for the first time, and the next phase begins. From day 4 through day 10, thermophilic bacteria take over. These are heat-loving microbes that thrive at 140 degrees and above. They tear through lignin and cellulose, the tough structural fibers in straw and leaves, at speeds that would take a forest floor a full year to match. From day 11 through day 14, the pile cools down and fungi move in to finish the job. Humus formation completes. The pile has shrunk by roughly half its original volume. The finished product is dark brown, crumbly, and smells exactly like the floor of an old-growth forest after rain. Now here's the payoff, and this is where the connection to dead soil becomes undeniable. Field studies have shown that a single high-dose application of properly made compost, enough to bring soil up to 3% organic matter, can restore highly degraded farmland that conventional agriculture had given up on. Microbial biomass, enzyme activity, and the stocks of nitrogen, phosphorus, and potassium all rise measurably within weeks, not years. The top 0 to 10 centimeters of the soil profile, the layer where most plant roots actually live, shows the largest gains in carbon and nitrogen content. For a home garden, you apply roughly 1 to 2 inches deep across the bed, which works out to about 20 to 60 cubic meters per hectare at field scale. Water it in thoroughly. Spray a compost tea on top a few days later to inoculate the broader soil profile beyond the application zone. Within a single growing season, soil that used to shed water like concrete starts holding it like a sponge. Structure builds, earthworms reappear, plants stop limping and start sprinting. A quick word of honesty before we get to the real reason this knowledge has been buried. You will see the Berkeley method paired online with something called bokashi fermentation in a product called effective microorganisms. The peer-reviewed evidence on bokashi remains mixed at best. 5 of the strongest scientific studies found no yield improvement when bokashi was compared against standard control groups. It can be useful as a kitchen scrap pre-treatment before adding materials to your main pile, but treating it as a standalone soil cure all is not supported by the data. Stick with the Berkeley core, add biochar and inoculants on top, and you have everything that has been validated. So why has this knowledge been so quietly kept out of mainstream agricultural conversation? The synthetic fertilizer industry generates well over $200 billion in global revenue every single year. That business model depends on one thing: dependency. Healthy, living soil produces food without recurring purchased inputs. After World War II, when munitions factories that had been making nitrogen for explosives needed a new market, agricultural extension services across the developed world pivoted hard toward chemical solutions almost overnight. University research funding followed industry partnerships, and traditional composting was left underfunded and unfashionable. The same erasure that wiped out countless indigenous farming practices applies cleanly here. The information did not disappear because it was wrong. It disappeared because nobody could sell it back to you. And that's really the heart of why this recipe gets called forbidden. The recipe itself is not secret. The science is published. The pile is sitting in your backyard waiting to be built. The forbidden part is that no one along the supply chain can extract a profit from your decision to build one. 14 days, 1 cubic yard of materials, free inputs, no permission needed from any institution, any consultant, or any chemical company. Traditional farming cultures across China, India, and pre-industrial Europe used variations of this method for centuries before modern science finally caught up and validated what they had always known. The microbes have been waiting in your soil this entire time. They never left. They are dormant, starved, and patient. The only question is whether you will give them what they need to come back to life. So, if your garden has been struggling, if your soil feels lifeless under your hands, if you have spent another season pouring money into bags of synthetic fertilizer and watching your plants underperform anyway, try this instead. Pick a corner of your yard this weekend. Stack a cubic yard of browns and greens at a 30-to-1 ratio. Wet it to the feel of a wrung-out sponge. Turn it on day 4, then every other day after that. In 2 weeks, you will have something the entire fertilizer industry would prefer you never learn to make. And the soil that has been waiting under your feet will finally have a chance to wake up.